Welcome back. We're continuing to look at multiplying and dividing rational expressions. Rational expressions are ratios of two polynomial expressions. In this video, we're going to look at multiplying. So when we look at multiplying, when I'm multiplying rational expressions, I'm taking, if I have A over B times C over D, I'm basically just turning this into one big division sign. So I multiply the numerators, A times B, divided by the denominators, B times D. The numerators A times C and the denominators B times D. So let's start out with a simple example. I have 6C over 5D times 15C D squared divided by 8A. This is essentially the same thing as just turning this into one big division sign with multiplication in the numerator and denominator. When I work through these problems, I like to combine like things, or group them at least, and stack them in the numerator and denominator. So in the numerator, I had 6 and 15 are just numbers. C and C are the same variable, and D squared, so I've got them on top of each other. 5 and 8 are numbers, so I'm going to put them here. I don't have any C's. I have a D, and I have an A. So now I'm going to work on simplifying just these numbers. So this 5 can cancel with a 5 from the 15, leaving me with a 3. And a 2 from the 8 can cancel with a 2 from the 6, leaving me with a 3 and a 2. This D squared and D will cancel to leave me with the D in the numerator. Nothing can cancel with the C or the A. So the numerator here becomes 3 times 3, which is 9, times C squared D divided by 2A. And that is my simplified problem there. So I turned this into one big division sign, grouped like things, and canceled from the numerator and denominator. A slightly more challenging problem, I have polynomial expressions in the numerator and denominator. I'm going to turn these, I'm going to put parentheses around here just to make this clear. And I'm turning this into one big division sign. So this is multiplication, so I can just extend that line through. Now I'm just looking at a simplifying problem because my numerator and my denominator only each have multiplication. So first step in simplifying was to fully factor. So when I fully factor x squared minus 6x minus 16, I get x minus 8 times x plus 2. And I also have an x minus 8 in the numerator. X squared minus 16 plus 64 will factor into x minus 8 times x minus 8. X squared plus 5x plus 6 will factor to be x plus 2 times x plus 3. At this point, I want to state the domain. I haven't changed the problem at all. All I've done is factored and turned this into one big multiplication. At any point in time, if I divide by 0, I have a domain restriction. So each of these cannot be equal to 0. So if I set x minus 8 not equal to 0, I get x cannot be equal to 8. I have a repeated, so I don't need to do that one twice. X plus 2 cannot be equal to 0, so x cannot be equal to negative 2. And x plus 3 cannot be equal to 0, so x cannot be equal to negative 3. These are my domain restrictions. Now that I've found my domain restrictions, I'm going to go through and cancel like terms. So x minus 8 and x minus 8, x plus 2 and x plus 2, x minus 8 and x minus 8. This leaves me with 1 divided by x plus 3 as my simplified expression with these domain restrictions applied. So to recap, we factored, stated the domain restrictions, and then canceled like terms.